recorded. All right, so let's go through this together. Okay. So let's see. All right. Okay, so let me zoom in a bit. So it's probably easy to see. There we go. Okay, so let me see. Can everyone see this? Oh, darn it. Back here. There we go. Okay, so good. Everyone can see this. Okay, so again, we're adding these two polynomials together. So again, I'm going to add it using the, what do you call it, the vertical method, okay? All right. Good. There we go. Makes it easier. Okay, so again, so it really doesn't matter which polynomial is the one that goes on top, right? And again, that's because you're adding here, okay? That's because you're adding. Okay, so what I did, I kind of did this, I guess randomly. I put the second polynomial on top, the x to the 6 here, okay? All right, so I thought there was a laser pointer here. All right, well, anyway, so what do we do here? So each term is going to get its own column, okay? So each term is going to get its own column. So we have x to the 6, that gets a column. X to the 4th gets a column, right? X to the x cubed, and then x as well. So we have those two columns, okay? All right, now, okay, so now we have to handle the other polynomial. And right away you can see, I did combine a few steps here, as you can hope, and hopefully you can see that. 5x to the 5th, well, that doesn't go in either of these columns, right? It can't. It can't go in any of those columns. So because of that, what has to happen is we have to make another column, and that's what I did over here. That's what I did over here. Okay, that's all right. That's what I did over here. There we go. Okay, so we have that 2x cubed. That would go in the x cubed column, so that goes here. All right, so that's good. X, again, we have the x column, right? So that's going to go in this column over here, okay? And of course, 1, right? Well, we don't have a column for a constant, do we? So we add that column, and that's what I did here. And now we put 0. Okay, so now we have all the terms from the first polynomial handled, and now we basically add zeros in. I did that over here, I guess, without thinking, instead of waiting till here, but that's okay. I mean, so for the blank spaces, we put 0 in as placeholders, then we combine by adding, okay? And that's what I'm doing here. Okay, so what's our answer? Well, these are the terms of the polynomial that is our answer. So that's what we get here. But we want this in standard form. I think, yeah, that's in the directions, okay? Okay, that is in, let me just make sure. If you can't see this, just let me know. I keep getting nervous that people cannot see it, but I think people can. So, putting this in standard form, well, the only thing we really have to change is we need the exponent of x to be decreasing as we go from left to right, and the constant term has to be on the end. So this 5x to the 5th would go over here. And that's what I do. Okay, that's good. I hope this one made sense. Okay, let's do the next one. The next one, again, is subtracting. Now, with subtracting, again, you really don't have a choice as to what goes on top. So this one has to be the one on top. And that's what we did. Each term is getting its own column, as you can see. Okay, remember, you keep the minus with the term. That's what I did. Now, for the polynomial here, well, right away, you can see that 4x to the 4, that doesn't go in either of these columns. So what do? We make another column. That's where this came in. What about the other terms? Well, 3x cubed, where would that go? In the x cubed column, so to say, right? Because 2x cubed and 3x cubed, okay, those are like terms. 3x squared, well, that's going to go in the x squared column. Okay, so that's going to go here. 9 and 4 are like terms, so 9 goes here. All the terms are handled. Okay, so again, you could leave this blank if you wanted. I put 0 in just to be on the safe side. I know in the first example, I put zeros in, some zeros in I put before than others, but that's okay. In the first example here, you can see that. I put these zeros in before these. That's okay. So now we put the 0 in to handle the blank spot. Then when we, did it? Oh, I see. It's kind of, all right, so I'll just do it down here. What happened was, I guess the table went on 2 pages. This was the top row, because now what we have to do is take the minus sign, right? And what we have to do is change it to addition and distribute the minus sign. So let me just go here. This is what I did, right? Hopefully from here you can see that, this changes into this is the second row of that table. I guess it got chopped into 2 pages. So this becomes minus 3x cubed. This, again, this becomes addition. You turn the minus over. That becomes minus 3x squared. This was 9. But then after we distribute, we get minus 9. This is 4x to the 4. We get minus 4x to the 4. So we basically get this table, but now we can combine the terms, and this is what we get. Yeah. And when you write out the answer, these are the terms of the polynomial, right? We write them out. But again, we want it in standard form, so really the only thing we have to worry about is this 4x to the 4. The exponents of the variable we want decreasing, so we have to move this to the front, and that's what I did here. Yeah? Someone have a question, or? Oh, someone asked for subtracting. Does it matter which goes? It does matter for subtracting. It does. The first polynomial has to be the one on top. So in number 2 here, someone asked for subtracting. Doesn't matter which polynomial goes on top. For subtracting, yes, the first polynomial has to be the one on top. It has to. Because subtracting, you can't just subtract in any order you want. So, okay, you're welcome. Awesome question. Okay. All right. I don't know how I missed that in the table. Maybe when I was making the PDF. All right. Any other questions? Okay. Okay. Let's keep going. Number 3. So 3 is another addition problem. I mean, the terms, there's some more terms here, but we can keep doing this. So for number 3, we're adding. Again, here we're adding. So the polynomial on top, that's up to you, because addition you can add in any order you want. So here, what we have then is, I put this one on top because there's more terms here. So again, each term, as you can see, is getting its own column. Okay? So each term is getting its own column. Move this up. So that's what happens here. For the other polynomial, we have to handle that, right? So the 7x squared, well, we have an x squared column. That's going to go here, as you can see. For 5x, well, you can see there's no x column here, right? So we have to make a column for that, and that's what we did here. Same thing for the 5. There's no column that has constant terms only in it. You can't put 5 in one of these columns because 5 and any of these terms, excuse me, any of these terms are unlike terms. So 5 gets its own column. Now we have these blanks. So what do? We put 0 in as placeholders. Okay, that's what we're doing. Put 0 in as placeholders. Okay, right? We do 0. You could put 0, or you could put 0x to the 5th. I'm doing x. I think it makes sense for more people. 0x to the 4, 0x cubed, and so on. Now we're adding, so we just combine, and we get this. 4x to the 5th. We get adding to 0 is just 4x to the 5th. Excuse me. 3x to the 4. We get 3x to the 4. 2x cubed, to add that, you get 2x cubed. X squared and 7x squared, that's 8x squared. 0x and 5x is 5x. 0 and 5 is 5. Okay, so now we just form the answer, and you can see it's already in standard form. Already now in standard form.